Hi, I'm Mr. Huber, and in this video we're going to talk about problem 1c. Well, find the vertex of each function, then rewrite it in general form, determine the y-intercept and make a qualitative sketch of the graph. If applicable, work out the zeros. Now look, f of x is 3 times x minus 3 halves squared plus 3. Well, the vertex is very easy to determine. It's at 3 halves, 3. Well, we already know it's a happy parabola. It is stretched by a factor of 3, and it will probably, we're sure already that it doesn't have any zeros, so it's not applicable here. But well, we'll see about that later on. So now the general form f of x is 3 times x squared minus 2 times 3 halves x plus 3 halves squared plus 3. You see, this is just a binomial formula. A minus b squared is a squared minus 2ab plus b squared. Okay, this is what I do here. Now, I wrote it up in a more exact way, or I did one intermediate step because I wanted you to see the binomial formula here. So let's carry on. 3 and then x squared minus 3x plus 9 quarters plus 3. Now you need to distribute. So this times this, this times this, and this times this. So you're going to get 3x squared minus 9x plus 27 quarters plus 3. Because you have to add 3 to this, you can go, write it in quarters. So that would mean 12 quarters. So f of x is 3x squared minus 9x plus 39 quarters. Well, 39 quarters could be written as a decimal number. Could be 9.75. Okay, you don't need a calculator for that. Now look, the y-intercept is in fact this, because when you plug in 0, f of 0, when you plug it in here, you can see it directly. It's 9.75, 9.75, or as I often prefer, 39 quarters. If you did it with this form, then you would have to calculate it. Okay, you would have to plug in 0 here. That would be 3 quarters squared. That would be 3 halves squared. That would be minus 3 halves to be exact. That would be 9 quarters times 3. That would be 27 quarters plus the 3. So it would lead to 39 quarters as well. So you're much faster. Once you have your general form, you can just read it off the graph. So the y-intercept is at 0, 9.75, or 0, 39 quarters. Now let's do a qualitative sketch here. And you see a qualitative sketch will come in very handy here. Here we go. We know the vertex is at 3 halves and 3. Let's go here. This is 3, this is 3 halves. See, it's not accurate. And then the y-intercept is going to be at 9.75. So let's say that's about here, 9.75. So this will be your vertex. So your graph is going to look somewhat like this. Try to have a rounded, nice and smooth curve. This is what your graph is going to look like. It gives you a very good idea of the graph. It's not accurate, but it doesn't have to be. It's just something that helps you to know what the graph looks like. And you see, it doesn't have any zeros. It does not intersect the x-axis. But well, if we had not seen this, or if we had not been able to draw the graph, we could still try and work it out. So f of x is 0. For which x is the y value 0? Obviously, once you see the graph, you know there is no x that satisfies this. But let's try. 3x minus 3 halves squared plus 3 is equal to 0. Well, first you need to isolate x, so that the first step is you subtract 3 on both sides. So minus 3, so 3x minus 3 halves squared. Then you divide by 3. X minus 3 halves squared is in fact minus 1. So first minus 3, then divided by 3. So you get this. Now you would have to take the square root. X minus 3 halves is equal to plus minus the square root of minus 1. Well, this does not work. There is no square root of minus 1 in the real numbers. So it does not work. That does mean it does not have any zeros. That's something we knew all along. Once we knew that it was a happy parabola with a vertex that's above the x-axis, you know that the parabola is not going to intersect your x-axis. So I hope it wasn't too difficult. See you in the next one.